Hello, I'm Xiwen. In my course project, I try to combine GLOW, an effective flow-based generative model, and the framework of deep density destructors, which allow building a deep density model by stacking many weak density models. First, let me briefly introduce flow-based generative models. Compared to other deep generative models, flow-based generative models have some very nice features. Unlike GAN or VAE, flow-based generative models allow exact latent variable inference and log likelihood evaluation. Unlike autoregressive models, flow-based generative models allow efficient inference and efficient sampling. Furthermore, the learned latent space is very useful for some downstream tasks. The basic approach proposed in 2014 paper NAS is to learn a bijective nonlinear transformation fx from a simple distribution to the observed distribution. So then the log likelihood of each sample can be expressed by the change of variable formula. Due to the time issue, we are not going to talk about how to learn a bijective function transformation using neural networks. Next, let's talk about the architecture of a GLOW model. We can see that each step of GLOW has three key components. The coupling layer is where the transformation is learned using neural network. Previous work, like real MVP, also use the same coupling layers they call a coupling layer. The actinome layer is very similar to batch normalization, which performs an affine transformation using a scale and Bayes parameter for each channel. The invertible one-by-one convolution is the key invention of GLOW. In flow-based generative models, after every coupling layer, only half the channels are transformed while the other half are kept the same. So the author proposed an invertible one-by-one convolution layer before each coupling layer, which can be seen as a generalization of channel permutation operation. Another building block of my course project is the framework of deep density destructors. The instructor has already introduced density destructor in class, so I'm not going to talk about this in detail here. So the question I'm going to solve is how to combine GLOW with the framework of deep density destructors. As shown in the figure, I choose to use one-step GLOW as a shallow density destructor. The difficulty here is that to stack density destructors together, each of them has to be canonical. By definition, it means the domain and the range of the transformation has to be from 0 to 1. So we add a logic function before each GLOW layer and add a Gaussian-based independent destructor after each layer. So by doing this, we make each GLOW layer a canonical density destructor. So now we can stack them together to build a deep density model. So here is the results generated by our density destructor using GLOW layer as a component. So we can see from the reset, although there are some patterns in the samples that we generated, the quality is still not good enough. The reason is we can see from the left, the learning curve on the left, we can see the reason is the density destructor failed to grow very deep. Actually, it stops to growing after it has 4 GLOW layers. The instructor and I still cannot figure it out why it stopped growing so quickly. Usually, a GLOW layer has 48 or even 90 GLOW layers inside it. So because we only have 4 GLOW layers here in our model, so we cannot learn a lot of structure in the distribution, and we cannot generate very good samples. In the future, I would like to keep working with the course instructor to figure it out what our model stops growing and try to make our model makes better to be able to generate more realistic samples. Thank you very much for listening.